In research, it is absolutely critical to distinguish between a population and a sample. We aim to estimate key values such as means, proportion, or differences in means and proportions for the entire population. However, we rarely have access to the full population, right? So instead, we collect data from a much smaller group in the form of a sample and then use that data to make inferences about the population. All the values that we calculate, such as sample mean, the sample standard deviations, are coming from that sample. We then use these statistics to estimate a range, typically with 95% confidence, within which the true population values are likely to fall. So in statistical terms, the population is the entire group of interest in a study, while a sample is a smaller representative subset selected from that population. For example, the population could be all residents of Framingham, while the sample would be the 5,209 participants enrolled in Framingham Heart Study. Another population could be all 30 to 60-year-olds with coronary artery disease in New York City, with the sample being a randomly selected group of, say, 50 such individuals. Similarly, the population could be all uterine cancer patients treated at Robert Wood Johnson Hospital, and a sample would be a random group of 50 such participants from that particular hospital. Since statistical analysis involves calculation, we use specific symbols. The values describing populations are called parameters, while values for a sample are called statistics with the lowercase s. In fact, if you see a statistics with uppercase s, that refers to the scientific discipline that deals with data analysis. So the key symbols include mean is represented, the mean for the population is represented by Greek letter mu, and the mean for the sample is represented by x bar. The standard deviation of the population is denoted by sigma, while that for the sample is represented by standard the symbol SD.